Ready?
Can't handle it.
All right, so today we're here to do a bunch of demonstrations about static electricity. So we're going to cover all of the stuff that's on the board here. It'll take all class period, so make sure you pay attention. This is the only time we're going to do these demos. It's just like when we did the thermodynamics demos. So we'll start here with the balloon, specifically this balloon. So when we talk about static electricity, what does the word static mean?
Stationary.
Stationary.
Look at that one.
So when we're talking about electricity, what are we talking about?
Stationary electricity.
What is electricity?
Electrons.
Well, electrons, it's all about charges, right? So what kind of charge does this balloon have? Zero, neutral, are you sure? You sure?
Positive.
Not anymore.
Okay, so, did that shock you when I touched you? No, he's okay. So, that means the balloon must be what? Neutral. Alright, so nothing special is going to happen here. So, there are three ways to get charge. What are the three ways to get charge? Y'all remember?
Friction.
Friction, what else?
Conduction.
Conduction and
Direct contact. Sorry.
Radiation.
Convection.
conduction is also direct contact. Starts with the I.
Insulators.
Insulation.
Induction.
Induction, there you go, good. So those are the three ways to get charge, and so we'll look at examples of that today. So here I'm rubbing the balloon on my hair. What's happening?
Creates friction.
Okay, never say create, say it's separating
Separating
the charges that are already there. Okay. So what's going on with the balloon right now? Seems to be sticking to my head. Why? Yeah. Well, that's exactly what's happening here. Is I've rubbed the balloon on my head. The balloon has become positively charged, and my hair has become negatively charged, and so they're attracted to each other. Yes. So y'all know that opposites attract and likes
repel.
repel. Yeah, that was weak. So opposites attract, likes repel. Say it again. Opposites attract, likes repel. Opposites attract. Okay. Trick y'all. Okay. So that's what's going on with my hair. So if I turn the water on here, just need a little bit. Okay. So if I take this balloon here and I bring it near the water, what happens to the water? Why does it move towards the balloon? It's attracted. So, what is water made up of? Hydrogen oxide is H2O. Okay, inside the water, sometimes one of the H's will break off and you'll have H ions floating around that are positive, and you'll have OH ions floating around that are negative. And so what happens here is if this is positive, when I bring it near the water, I actually force those positive ions back up into the pipe, leaving just the negative OH ions, making the water attract to the balloon. Alright? Any questions about that? So the last thing we're going to talk about with the balloon is this. What kind of charge does this wall have?
Oh, it's magnetic.
It's neutral. It has nothing to do with the magnetism of the board. Alright? That's a good guess.
It's attracting the charges of the wall to the
They are opposites.
Yeah. It does a thing that we call polarization. And this is very important because most students, when I say opposites attract, likes repel, you're like, okay, I got it. But it turns out that if you have a charged object, it will attract neutral objects as well. Okay? That's important to note. So basically what happens here is if we say that the balloon has a positive charge, if I got myself a wall here, let's see, positive, negative, positive, negative, negative, positive. So here I have just as many positives as I do negatives. So that means the wall has what type of charge? Neutral. When I bring the balloon near the wall, if the balloon is positive, what happens to these little electrons in the wall? Well, they'll be attracted to the balloon. Does that make sense?
The negatives will get closer to the balloon and the positives will go back.
Yeah. But overall, what's the charge on the wall? Still neutral because you have just as many positives as negatives. But the negatives, in this case, can come up closer to the balloon and they'll have enough force there to attract it. Everybody okay with that?
Does the balloon eventually lose its charge?
It's a good question. It absolutely does. So my next question is, how long does it take? How long will that balloon stay there?
30 minutes.
It's hard to say. It depends on two basic factors. Can anyone name at least one of those for me?
Gravity?
Height and weight.
Gravity doesn't really change.
Amount of charge?
The amount of charge, so where did it get its charge from?
Your head.
My head. So it depends on how much charge I put on it in the first place. The other thing that you're probably not going to be able to guess is it's based on the moisture content in the air. What do you call moisture in the air? Humidity. So the more humid the air is, the less time this will stay up here. Because again, it's got that moisture in the air, and those water molecules will come by here. The oxygen, it's electronegative. I don't know what that is. Look it up. It's electronegative, so it's going to come by here and it's going to want to steal electrons from this, or in this case, it's going to give off electrons. And so over time, that thing will eventually fall. Right? Any other questions?
If the room was filled with a charge, like a small enough charge, not like noticeable, but still there, would the balloon stay on the board for a long time?
What do you mean filled with charge?
Like, say instead of humidity, there was a charge in the air. Would the balloon just stay?
Oh, I see what you're saying. Yeah, no, it would come off a lot quicker. Does that make sense? Okay. Anything else? All right.